Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Multi-Agent Systems. When AIs team up to solve complex problems. Imagine you're building a massive software project. Could one person do it all? Probably not efficiently. You'd have a team. Front-end devs, back-end devs, QA, designers, each with their own specialized job. Multi-agent systems. MAS. Apply this teamwork concept to AI. It's when multiple AIs work together, each with a specific role, to solve problems that are too big or complex for a single AI to handle alone. Think of it as a collaborative brain trust of digital minds. Just like a single developer can't build Facebook overnight, one AI often struggles with highly complex, dynamic, or diverse problems. A single AI might be brilliant at one task, like playing chess, but it gets overwhelmed trying to manage traffic for an entire city or coordinate a global supply chain. MAS breaks down these mega problems into smaller, manageable chunks, assigning each chunk to a specialized AI agent. This allows for greater efficiency, flexibility, and robustness, much like a well-structured human team. In the context of MAS, an agent isn't a secret spy. Think of it as a small, specialized AI program or software module. Each agent has its own clear job, its own goals, and its own way of seeing and acting within a specific part of the overall problem. For a developer, you can imagine an agent as a microservice or a class object, designed to perform a particular function. For example, in a smart home system, one agent might manage the lights, another the thermostat, and another the security cameras. Each is independent but part of a larger system. A team only works if its members can talk to each other. Right? AI agents are no different. They don't just operate in isolation. They need to share information, request help, or give updates. This communication happens through defined protocols, much like how different parts of your software communicate via application programming interfaces. APIs. One agent might send a message saying, "Hey, the stock of product X is low," and another agent, responsible for ordering, might respond, "Got it, placing a new order." As a developer, you'd design these dialogues and interfaces. Just talking isn't enough. Agents need to cooperate and coordinate their actions to achieve a common goal. This involves setting rules for how they work together, assigning clear roles, who does what, and even establishing leadership or negotiation strategies if there's a conflict. Think of a conductor leading an orchestra, ensuring each musician, agent, plays their part at the right time. For a developer, this means designing the overarching logic or rules engine that governs the collective behavior of the agents, making sure they act in harmony rather than creating a mess. MAS is already at work all around us. Imagine smart traffic management. Individual agents control traffic lights, monitor vehicle flow, and even communicate with connected cars, all working together to minimize congestion in a city. Supply chain optimization. Agents manage inventory levels, track shipments, predict demand, and coordinate with different suppliers and warehouses to ensure products get to you efficiently. Robotics and manufacturing. Multiple robots, each an agent, might cooperate on an assembly line, passing components and performing specialized tasks to build a product faster and more reliably. Gaming. In complex video games, non-player characters, NPCs, can act as agents, each with simple goals, interacting to create a dynamic and believable virtual world. As a developer approaching MAS, think about these principles. 1. Modular design. Break your big problem into small, distinct agent services. Each service should have a clear responsibility. 2. API-first thinking. Define clear communication channels, APIs, and message formats for how your agents will talk to each other. 3. Define agent goals and behaviors. What does each agent need to achieve? How should it react to different inputs or messages? 4. Coordination logic. Design the rules of engagement, how agents resolve conflicts, prioritize tasks, or decide who acts next. It's about thinking in terms of a distributed, collaborative system, rather than a single monolithic program. Multi-agent systems are a powerful paradigm for building truly intelligent and adaptable AI solutions. By leveraging the power of collaboration, MOS can tackle problems that are beyond the scope of any single AI, leading to more robust, flexible, and scalable systems as AI becomes more integrated into our world. The ability for ICE to team up will be crucial for solving the biggest challenges. From managing smart cities to exploring distant planets, it's the next frontier in bringing AI out of individual silos and into a collaborative future. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.